Hey, fellow problem solvers, Colfax Math here. The only way you learn how to juggle is practice. The only way you learn math to be successful on a standardized math exam is to practice as well. I've written this book right here, Math Test Success. It's available on Amazon. It's about 15 bucks. And the thing about this book, it allows you that opportunity to practice. There are 25 chapters in this book. I have a video for every one of those chapters. But what I'm going to do today is this book is split into 5 parts. I'm going to go through this whole book in 5 videos. So we're going to cover a lot more content, move a lot quicker, but I'm going to do a lot of the problems that I didn't do in the previous videos. This book is your way to practice for the standardized math exam, whether it's an arithmetic reasoning portion of the ASVAB military placement exam or the mathematical knowledge portion of that exam. The math is the biggest part of it. It is also the easiest part to improve your score with practice and review. So with that said, what we're going to do today is we're going to go through part 1 of this book. There are 5 parts, 25 chapters. We're going through part 1 of this book, the foundational skills. That's going to include the number system in general, fractions, decimals, percents, unit conversions, and measurement. So those are the 5 chapters we're going to cover in this video today. You can get this book on Amazon. You could also get access to the videos earlier and additional videos by becoming a member of the channel. So with all that said, have this book out in front of you. If you don't have the book yet, have paper and pencil out in front of you. Get in the habit of pausing the videos, doing the problems before I do them, unpause the video, and watch how I do them. So to get started here are the 5 parts of the book, split into foundational skills, intro to algebra, more advanced algebra topics, geometry, and test-taking strategies. So the 5th video in this series is really going to be about test-taking strategies and how to do well on a standardized math exam. This is overall philosophy of myself, some of my background in teaching math. I've been teaching math in shop for a very long time. And maybe most importantly, before we start this video, I really want to dedicate this book and these videos and the whole Colfax Math program to all of the people, all the brave men and women who have served our country, served selflessly to make our freedoms a guarantee. So I appreciate all of you service members who have served in the past and who are currently serving. And hopefully this will help a lot of other people get into the service and help them serve their country as well. So with all that said, let's go ahead and get started in the number system, integers, fractions, decimals, how it all kind of works, including PEMDAS, that's order of operations, and we're going to go over absolute value. In this video, we're going to work through all 5 of these chapters, so it's going to be a long video, especially with you pausing it to do the problem. So let's go through this table of content, get down here to chapter 1, and get started. So let's talk about the number system, integers, fractions, decimals, how it all works. Let's start right here. This is kind of really where all of your math really begins. And it's such an important piece. It is actually the number line. This number line right here has arrows on each end to say it's infinite in both directions. There's a 0 here in the middle. As you go to the right, you're going positive. As you go to the left, you're going negative. The reason why this is so foundational is you're hopefully starting to put these pictures in your head. Later on, as you get to algebra, you call this number line x as an unknown variable. And then as you move into 2-dimensional space, you add a second axis in here. You call this axis y. And now you're working in a Cartesian coordinate plane. And then you have coordinates and lines and so forth. Okay, so we're on that number line right now. There are positive integers. You're just counting off 1, 2, 3, so on. This arrow is saying on to infinity. There are negative integers on this side going backwards, -1, -2, -3. And then the 0 is neither positive nor negative. Inside this number line, if you were to zoom in on this small little portion of the number line, 0 to 1 right there, what that would look like is you'd be breaking it into pieces. And those pieces, right, we're still on that number line. I'm just taking that 0 and to 1, and I'm breaking that into little pieces as well. These are non-integer numbers, but I'm going to still be on that number line. I'm going to take that 1, cut it in half, take that half, cut it in half. So here's half of a half or a quarter. So this is going to be 1/4, 2/4, 3/4. So I split that number line into quarters first, and that's where our first fractions come from. And then I'm going to take those quarters and cut them in half as well. Half of a quarter is an eighth, so I have 1/8. This would be 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, which is 1. I could split those in half again and get 1/16, 2/16, 3/16. And I could also write down those decimal equivalents. This is 1. It is the same thing as 1.00, right, or 100. If I take 1.000, whatever significance I have, I could cut that in half, and that would give me 0.5, or 50 cents on the dollar, or 25 cents on the dollar, or 75 cents of the whole 1. I could take that and cut it in half just like I did here. Half of 25 is 12.5. So this is 0.125. This one right here is going to be that 1/8 and that 1/4 added together to be 0.375. 0.5, I'm adding 125 each time. So this is 0.625. This is going to be 0.875, and then back to 1. So we're still on that number line. First thing we're doing is looking at integers, whole numbers, both positive and negative. Then we're going to zoom in and take that 1 unit and cut it in half, cut it in half, cut it in half to give us our 8 quarters. Then we're going to look at the decimal equivalent of those fractions. And then we're going to convert those to percentages as well. So this is 1.00, or all of it, or 100%. So this is 100%. Well, then half would be 50%. So this would be 50%. These are all equivalent. 50%, 1/2, 0.5. If this is 25, 0.25, it is the equivalent of 25%, still 0%, and 75%. And I should be able to go back and forth between my fractions, my percents, and my decimals. And the key ones, again, are all of the 8s. So this is 12.5%, 37.5%, getting a little messy here, 62.5%, and then 87.5%. Work on that number line, work on splitting it up, work on your equivalents, being able to count off really quick, 1/8, 1/4, 3/8, 1/2, 5/8, 3/4, 7/8, 1/2. I'm going to split that in half again. I'm kind of out of room here, but let me split that in half again. Now I'm zooming in even tighter, so I'm still between 0, I'm still between 0 and 1. I'm cutting that in half again. Again, that was, say it, 1/2, 1/4, 1/4, 2/4, 3/4. It's all about reps. You got to say it, see it, write it. I'm going to cut those in half. Half of a quarter is an 1/8, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, back to 8/8. I'm going to cut those in half now. Half of an 1/8, 1/2 times 1/8 is 1/16. So this is 1/16, 2/16, 3/16, 4/16, 5/16, 6, 7, 8/16. 8/16, right, is the equivalent of 1/2. 2 goes into here, 8 goes into here 1 time, 8 goes into here 2 times. 8/16, 9/16, 10, 11, 12/16, 13, 14, 15, 16, ending at 1. Make sure you could do that back and forth in your head, write it out, say it out, and keep practicing it. These are really foundational skills that are going to show themselves throughout this whole book. Okay, now we got that number line figured out. Let's see if we could apply some of those problems right here. I did do these in the previous videos, but I'll just say a couple quick things on this and we'll move to some of the other practice problems. What number 1 is saying, in my head I have this number line. I am at -7 and I am traveling 12 units and I am ending at 5. I'm counting out 1, 2, 3 all the way up to 7 spots and then 5 more spots to get 5. My answer here is 5. This is where I'm starting. I'm on number 4 right here. I'm on the number line in my head. I'm starting at -10. Here's 0. From -10, I go over 1, 2, 3, 4. That's going to put me at -6. Once I'm at -6, right, I go over 4 here. I go back 7 here. Well, -6 going back 7 is -13. So you want to use a number line here, do all of these problems. Here are the answers to those problems. And then we'll move on to fractions. You got to understand that number line first, and then we'll go over the rules of adding, subtracting, multiplying, and dividing. So to add fractions, the rule is the bottom number has to be the same. So right here, I have 1/4 plus 2/4. That bottom number has to be the same. It is. Now that I have that bottom number, called the denominator, the same, I add across the top and keep that bottom number. And that kind of makes sense, right? If I have a $1/4 plus a $1/2, I have 3/4 of a dollar. Where it gets a little trickier is when that bottom number is not the same. So here I have 2/5 plus 1/3. I have to get the bottom number the same. This right here is going to be one of the biggest ideas in math. Ready for it? Multiplying by 1, right? I multiply anything by 1, it doesn't change anything, right? So I have to multiply this by 1 so as not to affect the value of it. To get these the same, I need a lowest common denominator. That's going to be 15, the number that both of those go into, 15. To get this to a 15, I have to multiply it by 3. I can't just multiply something by 3, it's going to change the value of it, right? So I have to multiply it by 3 over 3. That's the equivalent of 1. Doesn't change the value at all, but it gives me an equivalent fraction, 6/15. Do the same thing with this. I need to get this to 15, so I multiply by 5. It's got to be a 5 over 5. That's going to give me a 15. So now I have plus 5/15. Remember I said the rule on adding and subtracting fractions, the bottom number has to be the same. So that's my first step. I have that bottom number the same by multiplying by the equivalence of 1. Now that I have them the same, I add across the top, keep the bottom number the same, and get 11/15. Okay, subtraction is really the same thing. I'm just going the other direction on that number line. So on number 1 here, I have 3/4 minus 1/4. Bottom numbers are the same. 3 minus 1 is 2. Keep that bottom number the same. I could reduce that fraction. 2 goes into here once, into here twice. 2/4, 1/2 are equivalents. They are equivalent fractions. This is just reduced. This one right here, we'll do number 3. They do not have a common denominator. I have 5, 6 minus 1/4. I need that common denominator. I'm going to start with the smaller fraction. The 4, the smaller denominator. 4, no. 8, no. 12. This will go into 12 and this will go into 12. How do I get 6 to 12? I multiply by a 2 over a 2. I multiply this by a 3 over a 3. That fulfills that rule. Get the bottom number the same. That gives me 10 twelfths minus 3 twelfths. I have that bottom number the same. 10 minus 3 is 7. Keep the common denominator 12ths. 7 twelfths. Moving on to multiplication right here. Multiplication is surprisingly easy. That problem is 1/2 times 3/4. All you do in multiplication is you multiply across the top, 3 times 1, multiply across the bottom, 8, and then you look to see if you could reduce that, and there is no way to reduce it. Final answer, 3/8. Division has kind of a funny algorithm to it. The way you divide fractions is multiplying by the reciprocal. So I have 1/2 divided by 1/4. The way I divide fractions is I multiply by the reciprocal. So what that means is to divide, you got to turn that to multiplication and flip that over. So 1/2 divided by 1/4 is the same thing as 1/2 times 4 over 1. Multiply across the top, 4. Multiply across the bottom, 2. And then I could reduce that. 2 goes into here 1 time. 2 goes into here 2 times. 2 over 1 is the same thing as 2. So 1/2 divided by 1/4 is equal to 2. And if we think about that, that kind of makes sense. What I'm saying here is how many times will 1/4 go into a half? Well, there are 2 1/4 and a half. Go ahead and make sure you do all those problems. Pause the video. There's the answer key right there. Talk about decimals a little bit. Adding, subtracting, multiplying. I won't do all of these. Pause the videos and do them yourself. The key to add and subtract is you have to line up that decimal. So I'll do this one, say right here. 12.8 plus 5.67. My decimal places are lined up. That's what I want. Now I just work from right to left. This would be the same as 0. 0 and 7 is 7. 8 and 6 is 14. Carry the 1. 1 plus 2, 3 plus 5, 8. 1. And then here's my decimal. So this plus this is equal to that. Subtraction is the same thing. We'll do one of these. 6.5 minus 2.87. My decimal place is lined up. I don't have a value here. After a decimal, I could put in zeros. And then now what I need to do here is I need to borrow. I need to borrow so I could do 10 minus 7. But this is the hundredths place. To make this 10, I have to take 1 away from here. So I have 10 minus 7, 3. 4 minus 8, I can't do that. So I have to borrow from here, making this a 5, and giving me 10 more units here. 14 minus 8 is 6. 5 minus 2 is 3. My answer is 3.63. Okay, remember to do that practice. Okay, let's multiply decimals. Here you're not lining them up, but you're keeping track of how far over they are. So let's take a look at this one right here. 4.7 times 1.3. 3 times 7, 21. Carry the 2. 3 times 4, 12. Plus 2, 14. Placeholder here. 1 times 7. 1 times 4. I add straight down. 1, 11, carry the 1, 6. I know it's not 611. My decimal is 1 over here and another over here. So it's a total of 2 over. I start right here. I go over 1. I go over 2. And I get 6.11. So the answer to this is 6.11. And that kind of makes sense, right? 4, a little more than 4 times 1.5 is in the ballpark of 6. It's kind of down on the page here, but number 17 for decimal division. 9.6 is going here, divided by 0.3. Well, I don't want to divide by 0.3, I want to divide by 3. So I'm going to move that decimal over one place. I could do that if I move this over one place. So now I have 3 into 96, 3 into 9 3 times. Bring down the 6, 3 into 6 2 times. Here's my decimal place. It goes straight up. How many times does 0.3 go into 9.6? It goes in 32.0 times. Again, do all of these practice problems here. Here's the answer key. Check your work right there. And we'll move on to percentages. Again, like where I started with that number line, remember a percent, a decimal, a fraction. They're all pieces of a whole, piece of 1. And that 1 could be written in a lot of ways. It could be written as 10 over 10, a million over a million. As long as the numerator and denominator are the same, it's the equivalent of 1. So what is 25% of 80? Easiest way for me to do this is convert that to a decimal. I think of this thing as like a little arrow shooting the decimal over 1, 2, or 0.25. So I'm going to do 80 times 0.25. If I start running numbers more and more in my head, I can recognize that as a quarter. Remember how on that ruler I split it in half and split that in half? I'm going to do that with that number 80. Half of 80 is 40. Half of 40 is 20. So a quarter of 80 is 20. I know my answer is going to be 20. Let's multiply this out. 5 times 0, 40. Placeholder, 2 times 0, 16. Add across, or add down, 0, 0, 10. Carry the 1, 2. My decimal's over 1, 2. Decimal goes over 1, 2, and I get that same answer, 20. The more you're able to visualize that original number line, the more you're able to do a lot of these problems quicker. Okay, I think I'll leave some of these word problems where we won't make it through these 5 chapters. There are all of the answers for those. Now we're going to talk about converting between that number line. So convert the fraction 3/5 to a decimal. That is actually not one of our quarter 8/16. It's a different denominator. So I have 3/5, and I know I want it to be a decimal. There it is as a fraction. Well, as a decimal, I know if I could get it to a 1, that's going to be part of a 1. So I'm going to do that same thing. This isn't going to get it to a 1, but it's going to get it close. If I multiply it by 2 over 2, I multiply by 1. That gives me 6 over 10. So 6 over 10, I want that decimal over one place. So I'm going to move it over one place here. So 3/5 is the equivalent of 0.6. So that's how I can convert it to a decimal. Or as a percent, there's 100% in 1 unit. So to go from a decimal to a percent, I go over 1, 2, and I get 60%. The more you play with those going back and forth, the quicker you're going to get at those. So here I have a decimal, and I want it as a percent. Well, 0.8 is the same thing as 8/10. There it is as a fraction. As a percentage, I would go over 1, 2 to give me 80%. 80 parts of 100, 8 parts of 10, 0.8 parts of 1. Those are all the same thing. They are all equivalents. All right, here's the answer key right here. Let's just talk a little bit about order of operations. And then we'll move on. So this is just a mnemonic device. PEMDAS. It says when you have a long equation like that, you need to do the parentheses first, everything in the parentheses first, then do all of the exponents, then do multiplication or division from left to right, then addition, subtraction from left to right. So right here, I'm going to do this first. This is in my parentheses 6 times 4 equals 5 times 4. I don't know what I'm doing here. Oh, sorry, this isn't 6. My mistake. This is 5. 2 plus 3 is 5. 5 times 4 is 5 times 4 is 20. Oh, yeah, reading's key. Okay, let's do one of these right here. So remember, I'm doing my parentheses first. 18 divided by 6, that's going to be 3. So I have that 3 plus 4 squared minus 7. So I've done my parentheses first. Next are exponents. That square right there is saying take that number, multiply it by itself. 4 times 4 is 16. So I have that 3 plus 16 minus 7. Then do the multiplication division. There isn't any. Then do addition subtraction, left to right. 3 plus 16, 19. 19 minus 7, 12. All right, should we do one more? Let's do number 4 right here. So on number 4, I have that 5 squared minus 12 plus 8. That's going to be 20. So in the parentheses is 20. Divided, this is a good one, by 4. 5 squared is 25 minus 20 divided by 4. I'm going left to right. I got to do division before subtraction. So I keep that 25 there. Minus 20 divided by 4, 5. 25 minus 5 is equal to 20. So that's it right there. Order of operations. There's the answer key to it. And then absolute value. This is just a way to check overall distance. So absolute value means whatever it is inside of these straight bars up and down, make it positive. Absolute value of -5 is 5. Absolute value of 3, it's already positive, stays 3. Absolute value of -1 million becomes a million. So calculate -8 plus 5 minus -3. That's actually not an absolute value problem. Minus and negative is a little tricky, but this is going to say -8 plus 5, -3, minus -3. Minus and negative is like plus, and that'll give you 0. Number 5 here, evaluate the absolute value -7. That would just be a 7 plus 2. That would be a 9. Okay, let's keep going. This is going to be a long. Here's a test at the end of the chapter. The first part, fractions, decimal percentages, order of operations, then absolute value, and then some mixed problems, some word problems right there. And then there's the answer key to it. And then that's going to bring us to more fraction problems, really working with fractions more and more. All right, let's get started with chapter 2. I know this is turning into a long video. Chapter 2 in the book is working with fractions, adding and subtracting fractions, multiplying and dividing, understanding decimal equivalents, multiplying and dividing improper, proper fractions, converting fractions to other equivalents, converting between decimals, percents, and fractions, and then practical word problems. I'm going to try and do all 5 of these chapters in this single video. So it's going to be a super long video, and I'm going to go through it pretty quick. We talked about fractions a little bit before, so we're just going to dive a little deeper into fractions. These are really such a fundamental problem for any math class, especially the ASVAB, both mathematical knowledge and arithmetic reasoning. A lot of things just get broken down to fractions. So for adding and subtracting fractions, the key to remember is the bottom number, the denominator, has to be the same. And then once it's the same, you add across the top and keep that bottom number. The numerator is the top number. The denominator is the bottom number. So if you have 1/5 plus 2/5, that's pretty easy because that bottom number is already the same. I add across the top to get 3. I keep that bottom number at 5. Where it gets harder is when the denominators are different. So when the denominators are different, like a 3 and a 4, I need to get them to a common denominator, and I want to find the least common denominator so I don't have to reduce that fraction. So the least common denominator between a 3 and a 4 is going to be a 12. So I have to convert that 1 over 3 into something over 12. I do that by multiplying by 4 over 4, multiplying by 1. That gives me 4/12. I multiply this by 3 over 3 to get 3/12. Then I add them together across the top to get 7/12. Okay, subtracting fractions is identical. You need that common denominator. Then you just subtract across the top, keep the common denominator. So if I had 5/8 minus 1/4, I would have to multiply this by 2 over 2 to get 5/8 minus 2/8. Then I would subtract across the top, 5 minus 2, 3. Common denominator, 8 on the bottom. Okay, with that said, pause the video and then go ahead and do all these problems. I won't do all of them. I'll just do a couple of them, and then we'll keep moving. The answers are in the book down below. I'll go ahead and do number 4 right here. So I'm looking for a common denominator. I have 4, 8, 12, 16. So I could see this is going to go into 12. This is also going to go into 12. So I'm going to take those 3/4. I want it to be the 12 in the bottom, so I'm multiplying it by 1, 3 over 3, minus 1/6. And I want this also to be a 12, so I'm going to multiply this by a 2 over 2. That's going to give me 9/12 minus across the top 2/12. I have that common denominator. I subtract across the top. I keep the bottom number the same to end with 7/12. Okay, so there's the answer key right there. Make sure you're getting those right. Okay, let's move on to section 2.2 in chapter 2, multiplying and dividing. Multiplying is really easy. You just multiply across the top. 2 times 4 is 8. Multiply across the bottom, 15. You could reduce that fraction. This one specifically you could check to reduce, but I could see there's no number that'll go into 8 and 15. Okay, here's another one. If I had a whole number, an integer like 3 times 1/4, I could turn that 3 into a fraction just by making it over 1. 3 over 1 and 3 are equivalent. So I have 3 over 1 times 1/4, multiply across the top to get 3, across the bottom to get 4. Dividing fractions is easier than adding and subtracting, but a little more complex than multiplying. The way you divide fractions is you multiply by the reciprocal. So you change that division into a multiplication, and you flip that over. So I have 1/2, I still have 1/2. Divided by becomes multiply. I have 3 over 4. I flip that over to get 4 over 3. Now I've converted that division fraction problem into a multiplication. Multiply across the top to get 4, across the bottom 6. My answer is 4, 6. That is correct. However, I can reduce it. So I can see that 2 goes into 4 2 times, 2 goes into 6 3 times. So 4, 6 is the answer. The reduced answer, the better answer, is 2/3. So let's do just a couple of these multiplication and division problems and then move on. So right here on number 2, I multiply across the top. 2 times 5 is 10. 3 times 6 is 18. I can see they are both even, so it'll reduce. 2 goes into there 5 times. 2 goes into there 9 times. My final answer, 5/9. If I want to reduce before I multiply, I could do that. And I could see that 2 would go into here once. 2 would go into here 3 times. And then I have 1 times 5, which is 5. 3 times 3, which is 9. Either way, you could reduce. Let's take a look at number 10. I have 8/15. divided by, so I'm going to change it to multiply, and I'm going to flip this thing around to make it 5/4. I'm going to actually reduce first. 4 will go into here once. 4 will go into here twice. So 8/4 is the same as 2/1. 5 goes into here once. 5 goes into here 3 times. 5/15 is the same as 1/3. I multiply across the top, 2 times 1, across the bottom, 2/3. If I had not reduced before multiplying, I could have said 8 times 5 is 40. 15 times 4 is 60. 20 would go into here 2 times. 20 would go into here 3 times. So it's easier probably to reduce before you multiply. Okay, so let's move on here. There are the answer keys. Hopefully you paused the video and did all those problems. And now we're going to talk about decimals and understanding decimals. So the first thing we want to know is the first thing after the decimal, that 1 right there, that is in the tenths place. That is 1/10. The 2 is in the hundredths place. That is 2/100ths. And then the 5 is in the thousandths place. That is 5/1000ths. To add and subtract decimals, you line up the decimal point and you add straight down, keeping the decimal point in its place. Okay, so go ahead and pause the video again and do these problems. The answer keys down below. I'll only do 1 or 2 of these. I'll just jump on number 3 here. I rewrite that 12.5 with the 4.87. Decimal point is lined up. There's no number here. It is after the decimal, so I could add a 0. 0 and 7 is 7. 5 and 8 is 13. Carry the 1. 1 plus 2, 3. Plus 4, 7. Bring that 1 down. My decimal place is here. It goes straight down. So 12.5 plus 4.87 is 17.37. Let me do one more here. Let me do 8. Looks like a hard one. I have 10.0 minus 4.37. So 4.37. I am subtracting. My decimal places are lined up. I'm going to have to borrow all the way over. So I remember I could add that 0 here, but I cannot do 0 minus 7. So I have to borrow. So I'm actually going to borrow from here, making this a 10. I'm going to borrow from that 10 and make it a 9. And then that's going to make this a 10. I'm going to borrow from this 10 and make it a 9, making this a 10. So then 10 minus 7 is 3. 9 minus 3 is 6. 9 minus 4 is 5. Decimal point comes straight down. So 10 minus 4.37 is equal to 5.63. I could double check that. I could add this plus this, make sure it equals 10. 10, move it over to give me another one here. That 9 plus that 10 is 1. That 1 and the 4 and the 5 give me the full 10. Adding and subtracting decimals, the point has to be lined up. Okay, let's keep moving on here. Multiplying, dividing decimals. So multiplying decimals, you keep track of them. So if I have 1.4 times 2.3, I multiply those two numbers together, and then I count over how many places over is the decimal to start with. 1, 2. I multiply those together to get 345, and then I come over 1, 2 to get 3.45. Okay, and then dividing decimals, I'm just going to move that decimal point over one place and here over one place. As long as I do it the same direction and the same amount on both of them, it's going to balance itself out. So I'm going to move it over to get 45 divided by 5, which is 9. Go ahead and do a couple of these right here. Again, answers are below. Pause the video and do them all. I'm just going to grab a couple. Whoops. Let's go ahead and take a look at number 3. I'm going to line the decimals up. 1.6 times 0.7. I'm not adding, I'm multiplying. So 7 times 6 is 42, carry the 4. 7 times 1, 7 plus 4, 11. Now I count over how many places is the decimal. It is over 1 place, over 2 places. I start here, I go over 1, 2, and I get 1.12. And that kind of makes sense because 1.6, 1.5, this is less than 1, so my answer has to be less than that. So 1.12 is 0.7 of 1.6. Okay, let's go ahead and do a division problem here. This is kind of a hard one here. I am saying 5.76 divided by 1.2. Well, I don't want that decimal there. I'm going to move it over 1 place. Remember, I can move it as many as I want as long as I move this over 1 place as well. So if I move this to the right one, I move this to the right one. 12 goes into 57 4 times. That's going to give me 48. I'm going to subtract 57 minus 48. I'm going to have to borrow 10 from this, making it a 4, making this a 17. 17 minus 8 is 9. I bring down the 6. 12 goes into 96 8 times. And then my decimal points right here, I bring it right up to get 4.8. Okay, we did those practice problems. There are the answers there. Moving right along, converting fractions to decimals. If I have the fraction 3/4, I am saying 3 divided by 4. How many times does 4 go into 3? It's not going to go in a whole amount. How many times does 4 go into 30? Well, it's going to be 0.75. Some of these you can remember, like a third is 0.33, 3/4 is 0.75, quarters, eighths. Those are all good ones to remember. So let's go ahead and convert some of these here. Some of these you should know, like a quarter to a decimal is 0.25. 3/5. Let's see if we could do this quicker than a long division. 3/5. 3/5. 3/5. Well, that's the same as if I multiply by 2 over 2, 6/10. Well, that's 6 parts of 10 or 0.6. Some of them, if I don't know, like 5/6 to a decimal, that one's going to be a little harder. What I am saying with 5 over 6, I think of that fraction falling over this way. So it falls over, that 5 goes down, and I'm saying how many times does 6 go into 5? Well, it doesn't. So I put a decimal there and make it 5.0. That decimal moves straight up. 6 into 50 is 8 times, giving me 48. 48 from 50 is 2. Bring down the 0. 6 into 20 is 3 to give me 18. 2, 20, I can see it's going to repeat itself. So 5, 6 is 0.83333 forever. And you could write that as 0.83. A little bar says that number is a repeating one. I'm not repeating the 8 and the 3, only repeating the 3. Number 6, convert this decimal to a fraction. That is 25/100ths. 25 goes into here 1 time, into here 4 times. So that is a reduced fraction. Okay, I know we're moving right along here. Jump to 2.6 between fractions, decimal, and percentages. If I have, say, 50%, if I have, say, 50%, good Lord, is my thing working? 50%, that is saying what part of 100? So that is 50 parts of 100. I think of this thing right here like a little arrow, and this saying go over 2 places. So I take the decimal and I go over 1, 2 to get 0.50. So from percent to decimal is pretty easy. And then this is 0.50 of 1, 50 of 100. So this is 50 of 100. So I could reduce that fraction. 50 goes into here one time and a here twice. So 50 over 100 is correct, but the reduced fraction is 1/2. Again, a couple to remember are your quarters, your halves, 3/4. You'll see those a lot on any ASVAB exam. And then 60% is like 60% is 6 over 10, 0.6, or 6/10 as a fraction. Then I could reduce that. 2 goes into there 3 times, into there 5 times. Okay, I think we got one more section here. Some more practice problems. Mixed conversions, being able to do all of those. Here are the answer keys to them. Oh, I'm missing a few pieces there. And then let's take a look at some of our word problems. So I'm still in chapter 2. I'm still hoping to get 3 more chapters in this video, but I'm just doing a quick overview of the whole book. A lot of practice in there. A recipe calls for 2/3 of a cup of sugar if you want to make half the recipe. Well, what I'm saying here is I'm starting with 2/3, 2/3, and I want to make half. So that's going to be multiplying by a half. 2/3 times a half, I multiply across the top to 6. And then I could reduce to 1/3. Let's take a look at one more here. Let's say a student scored 85% on a 120 question test. How many did they answer correctly? So I am starting with 120. I am going to convert this to 0.85. 0.85. Then I'm going to multiply to get 0, 10, carry the 1. 5 plus 1 is 6. 6. Placeholder. That's going to be a 0. 16, carry the 1, 9, I add straight down, 0, 0, 12, carry the 1, 10. How far over is my decimal? It is over 1, 2. So I go here, 1, 2, and my answer is 102. I'm going to look at that and see if that even makes sense. 85% of 120, yeah, 102 makes sense. All right, there's chapter 2. I know it's a quick race, but I'm trying to pack these 5 chapters into a single video. Okay, chapter 3, working with percentages, discounts, and more. What a percentage is, it's a way of expressing a number as a portion of 1. 50% is 50 cents on the dollar, right? So it is 50%, 0.5. Giving 100%, that means a full unit, 1. Okay? So the best way to do these percentage problems is to convert that percent into a decimal, like 0.25, and then I'd multiply that decimal equivalent, 0.25 times 80. I might be able to do that in my head because I'm thinking this is about a quarter. So this is exactly a quarter. So a quarter of 80, well, the way I find a quarter is I cut in half to get 40, that's a half. Half of a half is that quarter. Half of 40 is 20, or I can multiply it out. On discounts, these are kind of a little trickier. The discount amount is equal to the original price times the discount percent. The sale price is the original amount minus the discount amount. That is different from the markup. On a markup, the markup amount is the original amount times the markup percent. They won't really go back and forth because on a markup amount, you're starting with an original cost, say $10, and the markup amount, let's say, is 10%. So you're going to take 10% of the $10 to get $1. So then the selling price would be the $10 plus the additional $1 to be $11, right? However, if you go back, if you had a 10% discount on $11, 10% of 11 is 1.1. You would come down 1.1 to be at $9.90. So they don't go the same way. So markups and discounts you got to really keep track of. They're a little tricky. We'll do some sample problems to figure this out. So we're in chapter 3 right here, working on percentages. I'm going to do this one right here. I'm going to convert that. I remember this is an arrow shooting it over 2 places, 0.6. 250 times 0.6 is 0. 30, carry the 3, 12, 15. Decimal places over 1. I go over 1 to get 150. 60% of 250 is 150. Okay, let's jump down to number 4 here. A store buys a product for 80 bucks, marks it up by 35%. Again, I'm going to move that over twice. What is the markup amount and the selling price? So let's figure out the markup amount first. I'm going to take that 80, multiply it by that decimal 0.35. This is going to give me 0, 40, placeholder, 0, 24. I add down and get 2, 8, 0, 0. I am over 1, 2, so I go over 1, 2. So what is the markup amount? It is $28. What is the selling price? It is the markup amount plus the original price of 80 to get $108. So there's a markup problem right there. Just keep moving along. I'm trying to get a lot into this one video. Hopefully you paused that video and did all those problems. Here are all of the keys to them. Let's take a look at a percent increase and decrease. The amount of increase in a quantity expressed as a percentage is going to be the increase amount over the original price or the original amount. Percent decrease will be the decrease amount over the original amount. So let's go ahead and do one of these problems right here. So it is an increase amount. The company's revenue jumped from 500 grand to 600 grand. What is the percentage increase? Well, it went from 500 to 600. It went up 100 over the original amount, over the 500. Right? This is 100,000, 500,000. These zeros will cancel. These two zeros will cancel. What is the percentage increase? It is 1/5. That's my fraction. I want to get it to a percent. So if I get over 10 or over 100, I can multiply that by 2 over 2. Multiplying by 1 will give me 2 over 10 or 20 over 100. What is the percentage increase? 20 over 100 or 20%. Number 2, this is a decrease problem. So it is going to go from 8,000 to 7,200 down. That is a decrease of 800. 800 over the 8,000. Your zeros will cancel, will give you a 10% decrease. Okay, go ahead and pause the video, do all of these. Check them against the key right here. Okay, now we're going to look at some word problems here, still in chapter 3. Let's do a couple of these practice word problems. Again, pause the video, do them. I'll only do one of these. The answers are down below. I'll do number 1 here. A store offers a 25% discount or 0.25 or 1/4 on all items. Customer buys a jacket originally priced at 80 bucks. How much will they save? So this is key wording here. How much will they save? They are only asking you the discount amount. If you recognize that as a quarter, you could do a quarter of 80, 40, 20. They will save 20 bucks. They're not asking you the new sale price. They're asking you how much you will save, 20. If you don't see that, I do those quick because I practice them a lot. But I could just do 80 times 0.25. It's going to give me 0, 40, 0, placeholder 0, 16. That's going to give me 0, 0, 10, carry the 1, 2. Decimals over 1, 2, 1, 2 to give me the same $20 right there. Okay, let's keep moving here. A lot of practice problems. All the answers are right here in the key. Here's a test at the end of the chapter. I think if I do these, this video will never end. Make sure you pause the video, do these test problems, and then check them against the key down below. And then that's going to take us to chapter 4. Okay, moving on to chapter 4 and our first part of the book, Math Test Success. Again, this video is from this book right here. You could get this book on Amazon. And it's really nice to have it in front of you so you can work your way through the problems. I'm certainly not doing all of these problems, but I'm trying to create a video of the first part of the book, which is the first 5 chapters, and we're currently on chapter 4. If you're still here, I know this video is super long, but I thought I'd try and include this whole foundational part in one single video. Chapter 4, we're going to go over ratio and proportions. The first part, 4.1, understanding ratios. 4.2, understanding proportions. 4.3, solving different types of proportion problems. 4.4, applications of those. Test on chapter 4 with the answer key. And then we're going to go over measurement and unit conversions in chapter 5, and that's going to wrap up this video. A ratio is just one number compared to another number. So you could write it 3 different ways. You could use a colon, A is to B. You could write it as a fraction, A is to B. This is still at fraction form, A is to B, or the word A to B. So you're just comparing 2 quantities, and that's why it's so common, because the majority of the time in math problems you're comparing different things. That's where ratios come in. So if I had a sentence, 15 female students and 20 male students, and I wanted to create the ratio of females to males, it would be 15 to 20. I could write it like 15 to 20, and I could simplify that ratio because 5 will go into here 3 times, into here 4 times. So it'd be 3 to 4, 15 to 20. Those are equivalents. They're both correct. The important thing in the sentence is the order that the words come up is the order the ratio goes. So if it is 15 female to male, then this is female to male. If the question was how many females to total students, well, it would be 15 to 35 because the word is total, meaning you add both together. So here's a sample problem right here. A recipe calls for 2 cups of flour and 3 cups of sugar. So it is 2 flour to 3 sugar in that order. Express the ratio of flour to sugar in 3 different ways. So 2 to 3, 2 to 3, or 2 to 3. You could write it any of those ways. Again, the important thing is flour is first in the sentence, so flour comes first in the ratio. Okay, here's some practice problems right here. Pause the video, do these problems. The key's down below. I'm only going to do one of these, and then we'll move on, just so we're not here all day. We might be here all day anyway. A recipe calls for 3 cups of flour and 5 cups of water. Express this ratio as flour to water, 3 to 5. A company has 4 managers for every 20 employees. What's the simplified ratio of managers to employees? 4 goes in there once, goes in there 5 times, so it's 1/5. Here's the key to those problems, and that's going to take us on to section 4.2, understanding proportions. So a ratio is one number to another number. A proportion is when you set one ratio equal to another ratio. There are really a lot of proportion problems on the ASVAB mathematical knowledge and both the arithmetic reasoning problems. So are the ratios 2/3 and 4/6 proportional? So what you're saying is 2/3 equal to 4/6. One thing about a proportion is that the cross products have to be equal for it to be true. Cross product means they take the top right multiplied by the bottom left. 4 times 3, is that equal to the other cross product, 2 times 6? Yes, it is. 12 is equal to 12, so those are proportional. Here's one right here, number 1, solve for x. In the proportion, 5 is to 3 as 20 is to x. One ratio equal to another ratio, it's a proportion. I can solve that with the cross products. This times this, 5 times x is equal to this times this. 3 times 20, 60. Getting x by itself, divide both sides by 5, and x is equal to 12. So 5 is to 3 as 20 is to 12. Okay, let's work some of these problems here. Let's do number 5 here. Four workers can complete a task in 12 hours. How long will it take 6 workers to complete the same task? So this is workers, this is workers, this is task, hours of task. So I have one ratio equal to another. I am looking for this number. I might be able to say just pretty quickly, 4 times 1.5 is 6. Therefore, 12 times 1.5 is 18. 6 is to 18 is 4 is to 12. If they're easy numbers, and I could solve it that way. Or again, if I don't see that, I could find the cross product. 4x is equal to 72. Divide both sides by 4. And x is equal to that 18. Okay, moving right along here to section 4.3, solving proportion problems. So let's take a look at this. A car travels 120 miles, so those are my units, miles, in 2 hours. How far will it travel in 5 hours? So 5, this is hours here. This has to be hours here. I'm going to look for the number of miles. If it's an easy problem like this, I could see this is times 2.5. So this has to be times 2.5. Or I could cross multiply. So this times this, 12 times 5 is 60 plus that 0, 600 is equal to this times this, 2 times x. Divide both sides by 2, x is equal to 300. Well, that kind of makes sense too, right? 2 times 2.5 is 5. 120 times 2.5 is 300. The 240 plus the half, 60, to put me at 300. Section 4.4, applications of ratio and proportions. So here's an example. A recipe has 4 servings requiring 1.5 cups of flour. This one's a little tricky because we got fractions and decimals, but 4 servings is 1.5 cups of flour. How much flour? So I don't know how much flour is needed for 6 servings. Cross multiply. 4 times x is equal to 6 times a half. 6 times 1 is 6. 6 times 0.5 is 3. So 6 times 1.5 is 9. Divide both sides by 4 to get x by itself. These cancel, and x is equal to 9/4. Or that's an improper fraction, or is a mixed number. 4 goes into 9 twice with 1 left over. Correct answer is 2 1/4, 2.25 cups of flour for 6 servings. That's a good problem right there. You probably see something like that on the ASVAB. A lot of proportion problems. A lot of ratio and proportion, looking at different shapes. Let's take a look at this one right here. We'll see some more of these in geometry later on in the book, but these are really good ones as well, because proportional sides, the foundation of trig is that you have proportional sides. So 2 rectangles have sides of 4 and 6 and 8 and 12. So I have one rectangle that's 4 and 6. The other rectangle is 8 and 12. Are they similar? Well, I would set this up as 4 times 2 is 8. Then 6 times 2 would have to be 12. So the ratio of one side of the smaller rectangle would have to be equal to the ratio of sides in the larger rectangle. So is 4 to 6 equal to 8 to 12? Times 2 times 2, yes it is. So I could see, yes, they are similar. Okay, here's some practice problems right here. Pause the video, do them before I do them. Unpause, watch how I do them. A store sells 5 apples for $3. How much will 15 apples cost? Well, so cost is going to be down here. 5 times 3 is 15. 3 times 3 is 9. So the correct answer is 9. Setting them up this way, sometimes you could see them, and sometimes you're going to have to use that cross multiplication to solve. All right, I think that kind of wraps us up for Chapter 4, Ratios and Proportions. Here's the test at the end. Pause the video, do this test, and then all the solutions to these problems are down below it. All right, Chapter 5 of the book, Math Test Success, Success on the ASVAB. This is the final chapter in Part 1. I know it's a long video. If you're still here, you're doing great work. Make sure you're pausing the video, doing problems. The more you practice, the better you're going to do. With that said, let's talk a little bit about measurement and unit conversions, and then we'll do some sample problems, and that'll kind of wrap up this video. This idea of unit conversions is identical to the idea of multiplying by 1 to get a common denominator in a fraction. You could only multiply by 1 so as not to affect the value, and I'll show you what I'm talking about here. But with that said, first, let's just talk about the different measurement systems before we do any conversions. So in the metric systems for length, you have milli means 1,000, centi is 100. So a centimeter means there are 100 units in a meter. A milli means there are 1,000 in a meter. And then there are 1,000 meters in a kilometer. It's a pretty easy system, the metric system. Unfortunately, we don't use that here in the US. In the imperial system, there are 12 inches to the foot, 3 feet to the yard, and then 5,280 feet to the mile. I don't think people expect you to know that, but you do have to know that there are 12 inches in the foot and that there are 3 feet in a yard. If you're doing, rounding conversions, a yard is about the same as a meter. Okay, then when we're talking about weight or mass, in the metric systems, the base unit is a gram. A milligram is 1,000 grams, going down 1/1000th, and then a kilo is the opposite way, 1,000 grams to the kilogram. A kilogram is about 2 pounds. In the standard systems, there are ounces, pounds, and tons. In the imperial system, there are 16 ounces to the pound, and then 2,000 pounds to the ton. This is a complex one here, pounds and tons. There's a British ton and a US ton, and then there's a metric ton as well. But usually when you're talking about a ton in the US, you're talking about a standard 2,000 pound ton. I think a long ton is a British ton, and I think it's 2,200 pounds, but stick with 2,000 pounds to the ton. And then a metric ton is 1,000 kilograms, and it's like 2.2 pounds a kilogram. So a metric ton is about 2,200 pounds or 1,000 kilograms. Hard things to get your head around if you're not used to growing up with them. If we're talking about volume now, so X times Y times Z, how much water will go into something. Volume in the metric is milliliters and liters. In the standard system or the imperial system, fluid ounces to the cup, pints to the quart, quarts to the gallon. There are 4 quarts in 1 gallon. This is really hard to remember. 2 pints to the quart, and then 4 cups in a quart. And there are 12 fluid ounces to the cup. And the next set of measurements is seconds, minutes, hours, days, weeks, months, year. It's time. 60 seconds to the minute, 60 minutes to the hour, 24 hours to the day, 7 days to the week, 52 weeks to the month, 12 months to the year. That one we work with every day, so those are actually pretty easy. Okay, so to convert between units, if you're trying to get different units and do unit conversions, you're always going to multiply by a factor of 1. So if you know 2 things are equal, like 1,000 milliliters is equal to 1 liter, I could put 1 in the numerator, 1 in the denominator. They would have the same weight, so it would be the equivalence of 1. So with this said here, I just jumped up there, convert 2.5 meters to centimeters. So the way I do this is I write what I want, 2.5 meters, I'm going to keep units on here, 2 centimeters. So to cancel, when I multiply here, I'm going to have centimeters in the numerator, meters in the denominator. And then what that'll do is that'll allow me to cancel meters and meters, giving me what I want, centimeters. So how many centimeters to the meter? Well, let's see here. I don't have centimeters to the meter, but I have 1 centimeter is 10 millimeters. Oh, there it is. 1 meter is 100 centimeters. So 100 centimeters and 1 meter are equal. I am only multiplying by a factor of 1. Therefore, my units are going to cancel. I'm not going to change the value of it. 2.5 times 100 is going to make me move that decimal place over 2. 1, 2. To get 2.5 meters is the equivalent of 250 centimeters. Making a big deal about this multiplying by 1, but these problems are going to get pretty hard pretty quick. If you always go back to this idea of multiplying by 1, that is in fact the secret of conversions, the secret of common denominators and fractions, one of the trickiest things people have. Okay, so let's keep going here. Let's see here, imperial conversions here. Convert 3 feet to inches. So we know that there are 12 inches in the foot. I am starting with feet, so I have 3 feet. And I'm going to have to multiply by some factor of 1 here. Oh, don't tell me my pencil's going to start going crazy. I'm going to have to multiply by some factor of 1. I'm not sure what it is yet. And then I want it to be inches. So what that means is I have to put inches in the numerator, feet in the denominator. This and this will cancel, and that's going to give me inches, and that's what I want. Then I need to know that 12 inches are equal to 1 foot. My feet cancel, gives me 36 inches. You really kind of want to understand this idea when they're easy and you could do them in your head, and then take this idea to more complex problems. Okay, so let's take a look at some of these problems here. So let's do sample problem number 3. Convert 10 pounds to kilograms. So now I'm going a standard system to the metric system. I have 10 pounds, abbreviated LBS. I'm multiplying it by 1. I want kilograms, abbreviated kg. I know I need kilograms up here, pounds down here. Then I need to know that there are 2.2 pounds to 1 kilogram. So I'm going to have to do 10 divided by 2.2. Pounds are going to cancel. That's going to give me kilograms. That's what I want. This and this are equal, so I'm multiplying by 1. So that means I have to do 10 divided by 2.2. Think of that fraction, it falls over this way. How many times does 2.2 go in at 10? I'm going to move that decimal over 1. I'm going to move it over here 1. 22 into 100 is 4 times. It's going to give me 88. 100 minus 88 is 12. Bring down the next 0. 22 into 120 will go 5 times. It's going to give me 110. I could keep going here, but I could see it's going to be approximately, decimal is here, I bring it up, approximately 4.5. So approximately 4.5 kilograms is 10 pounds. Okay, let's keep moving here. Do some problems. Here are some word problems. So let's take a look at sample 4 here. A carpenter needs to cut a board that is 8 feet. The other thing about feet as well, it's 1 tick mark, and then inches, 16 inches are 2 tick marks. So I have 2 different units here. I need to do 8 feet into pieces that are 16 inches long. So for me to do that division, I have to have all the same unit. I'm going to convert that 8 feet into inches. I know there are 12 inches to the foot. That's going to give me 96 inches. And then I want 16-inch pieces into the 96. So how many times does 16 go into 96? The units are the same. And I think it's going to be 6. 6 pieces, assuming that there's no sawdust being made, that you're not losing anything to the kerf of the blade. Okay, let's keep moving along here in Chapter 5, measurement-related word problems. A rectangular garden is 12 feet and 8 feet. So I have 8 feet by 12 feet. Again, I'm going to put those little tick marks on there to keep track of my units. What is the area of the garden in square yards? This is actually a little bit of a tricky one. I could put these things in yards right now, or I could convert to yards when I'm all done. But if I'm in yards, 8's not really going to be an even number. 12 will be. So I'm going to divide each of these by 3 feet to the yard, giving me 4 yards. And then I'm going to divide this by 3, giving me 8/3 of a yard. Then I'm going to do 8/3 of a yard times 4 yards to give me 32/3 square yards. And then I'm going to do my division now. 3 goes into 32. Well, it goes into 30 10 times. Bring down the 2, it's going to be 10, that's my remainder, 10 2/3 of a yard. Okay, should we do one more here? Let's see. A lot of feet to inches. A bookshelf is 6 feet tall. How tall is it in inches? 12 inches to the foot. Feet cancel, giving me inches, and that's going to be 72 inches tall. Here's another square footage one, number 10 here. A room measures 15 feet by 12 feet. It's going to be a lot easier because these are divisible by 3. I want to know how many square yards. Well, 12 divided by 3 is going to give me 4 yards. 15 divided by 3 is going to give me 5 yards to give me a total of 20 square yards. Okay, let's see what else we have here. There's the answer key to that practice test. Here's a summary, and that's going to take us to our unit test at the end. I'll do a few of these and then we'll wrap it up so this video isn't forever. Okay, so again, remember to pause the video, do the problem before I do it, unpause the video, and watch how I solve it. 7 feet to inches, I'm just going to multiply that by 12 to get 84. 4 gallons to quarts. Well, I'm going to have to say 4 quarts to the gallon, so that's going to give me 16 quarts. 64 ounces to the pound, so I have 64 ounces, OZ. I'm going to multiply that 64 ounces, knowing that there are 16 ounces in the pound. And I know ounces have to go down here because I have to get rid of these. And what I want is I want pounds, so pounds have to be up top. 64 divided by 16, I think, is 4 pounds. Okay, here's some little more complex one. These are going to be multi-step conversions. So right here on number 7, a rope is 12 yards. I'm going to put that down in my units. And I want it to be inches. So I want my answer to be inches. I don't have a direct conversion, so I'm going to have to multiply it twice. 1 yard is 3 feet. Now my yards are going to cancel. That's going to give me feet. Then I got to get rid of feet. I know that 12 inches equal 1 foot. How am I going to do that? 1 foot. Right, so let's double check this here. 12 yards is where I'm starting. I want to end in inches. I multiply 3 feet equal 1 yard. That gets rid of my yards. Now I'm in feet. Feet over feet, those feet will cancel. And 12 inches equal 1 foot. So 12 times 3, 36. 36 times 12 is 12. Carry the 1. 7, placeholder, 6, 3. 2, 13, carry the 1, 432. So 12 yards is the equivalent of 432 inches. I am multiplying by these ratios of ones to get my units where I want them. Okay, let's do number 19 here. Convert 30 degrees Celsius. So I am at 30 degrees Celsius to Fahrenheit. I've seen this one actually on the ASVAB before. And I know that Fahrenheit is giving me the equation. Fahrenheit is equal to Celsius, 30 degrees Celsius. That's going to be that C, times 9/5 plus 32. That Celsius is just units, so I don't need to keep that in there. 5 goes into 36 times. Canceling just like I would cancel units. 6 times 9 is 54. 54 and 32 is 86. So 30 degrees Celsius is 86 degrees Fahrenheit. All right, well, hopefully this was helpful. Hopefully it's not too long of a video. If you're still here, congratulations. You're doing the work to do the very best you can on your ASVAB military placement exam. This is only, again, going over the math portion, the mathematical knowledge and arithmetic reasoning. Any questions, please post them in the comments. Get this book, work your way through this book. And that'll help a lot. The more practice you do, the better you're going to get. I appreciate you watching and supporting the channel. Thank you.